Hello, good morning everyone. A very warm welcome to PhotoView 360 webinar, the one-button photorealistic rendering software inside SolidWorks. My name is Pradeep, representing Beacon North, based out of Delhi. And today we'll be talking about all the photorealistic rendering capabilities of SolidWorks. And I have got a content of about 30-35 minutes, maybe even 40. And we'll follow it up with Q&A. So I think we're right on time, so we can start off. If you have any questions, queries, please let us know through the chat windows so that we can assist you with that. And at the end of the webinar, we'll have a dedicated Q&A session. So let's start off. The images that I have on my screen are the exact data set that I'm going to use for today's webinar. It is a toy car made out of Lego pieces. If you're familiar with Lego and if you have used them when you're a kid, you know they're a blast. So I thought I'll choose some data set which is very simple in nature, but yet will reflect all the nuances and capabilities of PhotoView 360. So why do we need rendering in the first place? Why do we need rendering? Why do we need a dedicated rendering module called PhotoView 360? So the two images I have put on the title slide, I think they drive the point that I'm trying to make. So the image on the left is a SolidWorks 3D CAD model. The image on the right is again a SolidWorks 3D CAD model. So what's the difference? The benefits of using photorealistic rendering software like SolidWorks PhotoView 360 go beyond simple benefits. They make your models more presentable, visually more pleasing, and more readable. If you think about it, the image on the left doesn't make as much impact, as compared to the image on the right. But again, when you talk about the content or when you talk about the dimensions, the geometry, or the design that goes into it, both are exactly the same. But when you're presenting to your customers, clients, or when you're putting up pictures on your websites, definitely having a photorealistic rendering software like PhotoView 360 inside SolidWorks will definitely help, and it will give you a clear edge over your competitors. This is a simple model, as I said, a Lego toy car. You can find the model at 3dcontentcentral.com. And this presentation actually was intended to be a hands-on session, but I have converted into a webinar. So let's see how it goes. Again, I'll be sharing the complete PDF with you so that you can actually practice the same at your end. So you'll get an email after the webinar. About the hands-on PDF as well as the dataset. And this presentation was originally done in SolidWorks World 2012 by Rob Rodriguez. So I'm just repeating the presentation of his. So this is our agenda for today. We'll be talking about SolidWorks photorealistic rendering capabilities. As I said earlier, the name now is called PhotoView 360. Earlier it was called PhotoWorks, and it was not an integrated solution. Now I think after 2009 or 10 or somewhere around that, SolidWorks has completely integrated PhotoWorks into SolidWorks and then renamed it to PhotoView 360. So the agenda is pretty simple. We'll talk about the user interface. We'll talk about all these different aspects of photorealistic rendering like appearances, decals, camera, scenes, lighting, and then output options, etc. But again, this webinar is intended to be a very basic introduction to PhotoView 360. I actually wanted to do a two-part webinar, wherein in the first part we'll be covering all the basics of PhotoView 360, and then in the second part I'll cover the advanced aspects of PhotoView 360 like rendered animations or having some caustic effects, etc., playing around with the optics, light effects, etc. So PhotoView 360, although it might just look like a bunch of buttons on your command manager, you can really get amazing effects out of it. If you just go to your search engine and type, you look up for SolidWorks rendered images, you see fantastic content generated by users all around the world. And in my presentation today, I tried to include some of these pictures just to show you how how much impact these CAD models can create just by using the PhotoView 360 or the render tools inside SolidWorks. Again, I'll be spending a good amount of time on appearance hierarchy. I think this is understanding the hierarchy is really important for us to go ahead and do any advanced renderings or advanced um, capabilities of PhotoView 360. So we'll also talk about various workflows. I mean, there are a bunch of different ways that you can work with. We'll try to create a camera. We'll try to apply or edit some scenes. We'll see how lighting works, and then we'll have some decals, etc., etc. So again, if you are already an existing user of PhotoView 360, this might just recap or brush up your fundamentals. But this webinar was intended towards the very first-time users of PhotoView 360. So before we get into any detail, first I want to make sure that we understand the differences between SolidWorks render tools and PhotoView 360. So as I said, PhotoView 360 was brought in the year 2009 or 10. Before that, it was existing as a separate standalone application called PhotoWorks, although partner product. They made it completely integrated inside SolidWorks now. And PhotoView 360 bundles with every seat of SolidWorks Professional and every seat of SolidWorks Premium. Unfortunately, at this point, it is not available with SolidWorks Standard. So whatever we are talking about today would be mostly available in Professional and Premium. Although we'll be again looking at some of the basic features. If you look at the picture, I have a snapshot of the Command Manager tab of PhotoView 360 or the Render Tools. In SolidWorks, it will be called as Render Tools. So again, I have split them into two parts. The first part is what I call as rendering tools in SolidWorks, and the second part is PhotoView 360 options. So before the year 2009 or 10, whenever the integration happened, you never had all this options like editing the scene or editing the decal. Although you had some basic options like adding appearances. So now, if you have SolidWorks Standard, you'll have the first 3 icons available to you, and the rest 6 will be grayed out. But if you're on SolidWorks Professional or Premium, you'll have access to every one of these. But again, if you're seeing them grayed out, it means that you haven't checked the add-in of PhotoView 360. In a couple of minutes, we'll see how we need to add in the plugin. So again, there are 2 ways to go about it. First is, you add appearances, you add scenes, or you add decals, you make all your settings, and this can be done in every seat of SolidWorks, meaning Standard, Professional, and Premium. But when you want to render it, then you need a PhotoView 360 option, which comes with Professional and Premium. So first up, we'll talk about appearances. You might have all seen this earlier. You know about appearances. You use appearances on a day-to-day basis. But for this particular presentation, the word appearances and material can be interchanged. Can be used. I mean, they both are the same for me, because every material carries an appearance with that. On the picture on the right, you see the appearance of alloy steel. This is actually a snapshot of the material database property manager. So every material carries its own appearance. In this case, I'm showing you an appearance that is bundled with alloy steel. Or let's say if you want to override it, you always have the option of going onto the right task pane and browse to appearances and add something very specific in nature. Like it can be a paint, or it can be something organic like the picture that I have on the bottom. You can even add a texture, something like grass or stone or rubber. You have a lot of options. So again, after this, we'll try to understand appearance hierarchy. This is really important when it comes to assemblies, when you have complex assemblies, and when you are adding appearances to almost every single part of the assembly. It is important to understand this appearance hierarchy both at a part level and at an assembly level. Here in the slide I have just mentioned the hierarchy, how it works. At a part level, faces are the supreme. Faces override features, feature override parts. At an assembly level, components are the supreme. Components override faces, faces override features, features override parts. At this point, I'm pretty sure that it doesn't make any sense to you, but just hang on till we get into the product hands-on, so that you'll get to know what it's all about. But just to put it on the slide, I have both the hierarchies here. Next up, we'll talk about decals. This is again a fantastic option when you're talking about bringing in any of the labels like product labels or company labels, company logos, warning labels, etc., etc., at the design stage itself, so that you can strategically place these images wrapped down to your models, so that you can visualize for space issues at that design stage itself. So this is quite a powerful capability. You can bring in any of the images, BMP, PNG, JPEG, etc., etc. You have again advanced options like you can mask the image, you can use alpha channel. When it comes to the mapping, you have different kinds of options like projection, spherical, or cylindrical, and you can have some advanced options like eliminate your labels or decals. So we'll look into all of this. So again, as I said, this particular picture, whatever you're seeing on the PowerPoint, are all SolidWorks images. These are products made in SolidWorks, and they're not actually the real photographed images. They are the actual rendered outputs of SolidWorks. The scenes, we'll talk about some scenes. Every SolidWorks template, every SolidWorks part or document that you have ever seen in 3D will have a basic scene. It can be it can be as subtle as that you won't even notice that it's there, but what makes this all your 3D CAD visible is the scene. It'll provide a lighting, it'll provide a spherical environment, so that when you rotate, you're able to view all the aspects of your geometry, and then you'll have a 2D background, and you can have a 2D floor. So we'll dig into the scene. We'll interrogate what goes into making a scene, or how do you go about editing it, and what all you can control. As I said, you can control a bunch of lighting options. You can control the floor settings. You can control the background. Like you can have an image as a background, and then you can go about and render it. And then we'll move on to cameras. Cameras are again inbuilt option. It's a fantastic option. Mostly people use it for walkthroughs, but I like to use it for rendering, because you can exactly get the kind of output that you will when you're actually doing a photo shoot with your prototypes. I mean, I have actually noticed this with a lot of my customers. I mean, they typically, when it comes to consumer products, they'll be eagerly waiting for prototypes to come out, so that they can have images taken out and put on the websites or on the brochures for marketing purposes. But when you have a 3D CAD software like SolidWorks, you don't have to wait all that long. They can immediately get started along with the design process. They can start off by creating images using SolidWorks render tools like PhotoView 360, and you can specify the position of the camera. You can specify the area of the model where it is looking at. So the way camera works is the window will be split into two. The first half, the left portion of the window will be the camera position, so you can position it appropriately, and the second half will be reflecting what you see from the camera. And you have a lot of options like depth of field. You can have a lot of options like the placement options, or all the other camera options. You can specify the type of lens that you are looking through. So we'll take a detailed look at it when we are on SolidWorks. And then we'll come to lights. I don't want to go too much into lights today because it might be a little bit of overhead. We'll definitely try to understand how lights works. You can play around with lights like on the image that you see of vitamin water. There are two halves of the image. One half is they're not using much lighting effects, and the second half you have actually used a lot of directional lights. So you can bring out your image, products in a very, very impact making fashion as such. You can control the shadows, direction, shadow, strength, etc., etc. And you have 4 different light types: ambient, directional, point light, and spotlight. By default, every scene in SolidWorks will contain 1 ambient and 3 directional lights. So you cannot play around with the ambient light, you cannot delete it, you cannot get rid of it, because that's what is making your 3D models visible in the first place. But you have a lot of control over the directional lights. You can turn them on and off in SolidWorks and then in PhotoView. And then you can add point lights or spotlights as required. And then we'll talk about output options. I don't want to explain this right now, but let's dig into SolidWorks and then we'll come back to this later. So here I have SolidWorks 2012, and this is actually a premium license. So I have PhotoView 360, but let me do one thing. Let me take off PhotoView 360 for one quick second, and let me start SolidWorks. Let me open up the toy car assembly. So here I have a 3D assembly, a SolidWorks assembly of the toy car. It's actually a car made of all the Lego pieces. And on the command manager, we have option to turn on the render tools tab. So once I turn on the render tools tab, this is where I get all my PhotoView 360 options or the render tool options. As I said earlier, these 3 options will stay on, will be available with standard, professional, and premium. But whereas the next 6 will be available only with professional and premium, meaning they are available with PhotoView 360 checked in. So right now, even though I'm on a premium license, I cannot see all the 6 options. They are grayed out because I have unchecked, or I have not checked in the PhotoView 360 add-in. As I said, even standard users can leverage all these options like editing appearances, editing scenes, and editing decals. So let's stay on standard for some time, and then we'll bring on the PhotoView 360 options when we need it. So for now, let's stay on this. As I said, this is a toy car assembly. You can see that there are some Lego pieces which are already having some appearances, and some are not. So let's start with this tires. So I have 4 instances of this TC_tire component. So let me open up in SolidWorks and see how we can add appearances to it. So on the right, you have your appearances, scenes, and decals tab. So we'll pin it for now, so that we need this throughout this presentation. So let me pin it here, and you can dig into appearances. So this is a tire which is quite rubbery in nature. So you can go and pick rubber. You have glossy rubber, you have textured rubber, you have matte, but I don't really care about all this. I just want to go into something like a textured plastic. So in plastic, you have a lot of options. Let's dig into textured plastic and let's pick this material. So as long as you're in a part mode, you can just double click the appearance and it will automatically add the appearance. So you can see that we have a textured plastic applied. And remember, we are doing this at part level because we have opened the part in a new assembly. And if you, on your feature manager, you have appearances tab, display manager, wherein you have appearances tab. So here you can see the material that we have applied. So you can sort your appearances in 3 different types: history, or by alphabet, or by hierarchy. We'll be spending some time in hierarchy, especially when it comes to assembly level. we'll dig into how to understand this assembly hierarchy and what it actually means. So for now it's just only one appearance, so we have added it, we're all good. So we can go back to our assembly and see how this has changed our model. So we have already started to notice some changes. All the 4 parts are updated, even though we have opened only single part. Since these are instances of each other, SolidWorks has applied the appearance to all the 4 tires. And you can see that something is not right about this model. You can see the floor offset, it's not right. But again, this is due to scene setting problem. So we'll get to this when we are doing the scenes. So most of the time I see users struggling with this. You have a shadow which is off your model, the tires are in the air and the shadow is on the ground, so you need some offset here to be corrected. And one more interesting setting here you can do is ambient occlusion. This is a new feature in 2011, 12 I believe. So when you check this on, you'll get a very nice occluded effect, which actually does some kind of real-time rendering, so your models look very impressive. But this can actually be a little bit slow. As you can see that when I'm rotating my model, the shadows are disappearing and the reflections are disappearing. So it's a little bit slow, good for presentation purposes, but on a day-to-day basis I won't use that. So let's get rid of ambient occlusion. So we have added appearance to all the 4 tires. So let's go back to the display manager at an assembly level and see how how it has been added. So here we have appearances sorting in the order of in order in which they were added, basically history. So I have these white, black, and red plastic medium gloss added earlier, as well as the polycarbonate plastic, which is basically a transparent material here. And then the last one is the tire medium gloss textured plastic added to the tires. So it is last in the hierarchy, but since this is a history based, it doesn't mean much. So let me go back to hierarchy mode. So now we have 2 different types. One is components, one is parts. So we'll understand the difference between components and parts in just a minute. So for now, we'll look at a different way of adding the appearance or the material. As I said, these 2 words are interchangeable. So now let's focus on these rims. So we have 4 different rims. So let's add some appearance to these rims. So one way of doing it, you open it up in a new window and add the appearance. But let's stay in the assembly mode and see how it works. So I'll go to my appearances, scenes and decals, task pane. Let's look for medium gloss plastic, and I want a yellow plastic. So what I'm going to do now is I'm going to drag and drop this material or appearance. I'm dragging and dropping it onto the surface of the rim. So as soon as I drag and drop it, I get a contextual menu. So what is interesting about this menu is, as you hover over different options, you have option of choosing the face on which you dragged it onto. You have the option of choosing the feature, which is a boss extrude, or you have option of choosing the body. Okay, all these 3 are at a part level, and the 4th one is part, 5th one is component. So I want you to understand the difference between these 2, because the other 3 are basically geometry related. Basically it depends on let's say you want to apply the material or the appearance only to a particular face, you choose the first option. If you're choosing the next option, it will basically choose the entire feature on which you dragged and dropped it into. And if you are choosing the body, if you have solid body, it will apply it to the complete solid body, same as the part. But I want you to understand the difference between the part and the component. So when I hover my mouse around the part, you can see basically all the 3 rims which are visible to you at this point are turning yellow. Basically they're accepting the appearance. But when you go to component, only that particular component on which you dragged and dropped the appearance onto is holding on to the appearance, and the rest are staying as is. So I want you to understand the difference between part and component, because this is important when we go to the understanding the hierarchy. So for now I'll choose part, because I want the appearance to be on all instances of this rim. If you want only for this particular instance of trim to be affected by this appearance, you choose the component, but for now I'll choose a part which will apply the yellow medium gloss plastic onto all the 4 rims. So now again in hierarchy you have this appearance is applied at a part level. So next up I'll open up this chassis part. This is the first part of the assembly. It's a big piece of plastic, so let me open it up in its own window and let's add some appearances to it. So this is the standard Lego piece that you get, and I want it to be red in nature, red medium gloss plastic. But let's go a step ahead and let's see, if you are taking a look at this number 01, I want some nice effect here. So you have a boss extrude which is corresponding to this particular feature. So what I'll do is I'll pre-select boss extrude and I'll choose a black medium gloss plastic. So all I have to do is pre-select the feature and double click. It will hold good, or you can do the same by dragging and dropping the appearance onto the feature. So for now we have red for the at the body level, or sorry, at the part level, and black medium gloss plastic at the feature level. So let's go to the appearance tab of the display manager appearance tab and see how the hierarchy is updated. So let me choose appearance hierarchy, and you can see that I can try to understand now how the hierarchy works. Basically, first we have applied red medium gloss plastic to at a part level, so the complete part is in red. But then we added black medium gloss plastic onto the boss extrude feature. So now the boss extrude feature is overriding the red medium gloss plastic applied at the part level. So this is how the hierarchy works. Features override parts. Basically, faces will override features. Let's see how that works. So what I want now is the inner face of this 0 and the inner face of this 1. I want them to be in white. So what I'll do is I'll pre-select these two faces. I'll double click on white medium gloss plastic. So you can see how, let me get rid of the task pane. We don't need it for now. So we have red medium gloss plastic applied at a part level, and then we chose the black medium gloss plastic for the feature, and then white medium gloss plastic for the face. So faces override features, features override parts. This is how you want to remember it when it comes to the appearance hierarchy at a part level. We are at a part level. When we go to an assembly level, we have one more component adding in, which is at component level. So let's see how this looks. What I'll do is I'll turn on the render tools and I'll turn on the preview. Oh, I don't have a preview. So let me bring in PhotoView 360 now. I think we need to have the PhotoView 360 now so that we understand how it looks when it is rendered. So you have different workflows here. You have integrated preview, you have preview window, etc. You can split the windows. I'll talk about that. But for now, let's have a preview window. So what this preview window does is it renders the part and gives us in a different window. So we can zoom in and see how this effect is taking place. Pretty good. So what I'll do is I'll just resize this window. I don't want it to be too big because the smaller it is, the faster it will render. So we are done adding materials at the part level. So we'll go back to the assembly, and this is how our assembly will look. And when you render it, this is how it's going to look. So next up, we have some more components which are without any appearances. I have the axles here. I have the dash. I have the seat. So all these components are not having any appearance. So let me quickly add some appearance to it. So I'm again choosing to add an appearance at an assembly level. So what I'll do is I have pre-selected these items from my assembly tree. I'm gonna double click a particular material so that they'll be added. So I have chosen light gray plastic for all these different materials. So if you go to that display tab, appearance manager, you can see we have chosen to add these appearances at a component level. So when you're double clicking at an assembly level, it's going to add at a component level. But if you want to stick it with the part, you need to open it up in a separate window, or you can drag and drop it and choose the part option explicitly. So for this reason, if I open this seat in a different window, it won't have any appearance at a part level. Nothing is there in your appearance tab. But at an assembly level, you have added it at a component level. So components override faces override features, and features override parts. So at a component level, the default part appearance has been overridden and it has been applied. So it's okay. Now we don't have to worry too much about this preview, because this is not how it's going to look. It's going to look like a light gray medium gloss plastic. So what I have here for you is a decal, adding a decal. So let's go and add a decal. Currently there is no decals here. So we can open the decal library from here, or you can launch your task pane and go look for the decals. So SolidWorks basically bundles with a bunch of default decals, and you can add images to this. You can add folders to this, any other image that you want to do, like a barcode or a warning symbol, anything you can. For now, what we'll do is we'll try to see how do we add a decal and how do you control all the options. So what I'll choose is this standard decal, which bundles with every seat of SolidWorks, basically designed with SolidWorks logo. So I'll just drag and drop it onto this flat surface of the back. So as soon as I drag and drop it, SolidWorks is giving me a preview of how it's going to look. But what's more interesting is you have a lot of options here in the decals tab, decals property manager. You have 3 tabs. One is the image. You can either go and add an image or locate the image from here, and you can save this particular image in your decal library. And the second options are about masking. We'll get to masking in a little bit, but first let's go and map this particular image. You have controls in the graphics area as well. You have this bars using which you can drag them and resize them. Currently we have an aspect ratio which is fixed, so you can uncheck that if you want to lose the aspect ratio and stretch the image in such a way that it fits your geometry. Or you can use the fit width selection option. You can mirror it horizontally, or you can mirror it vertically. So all different options are there in mapping. And as I said, you can rotate it. You can use these handles to rotate it. So let's go back to the image. What I want to talk about are the masking options. Here we don't have any mask here, but if you want to, let's say, use this particular option, selective color mask, you can get rid of this particular color. You can see in this preview that this is going to look whitish when it comes to the preview or the rendering images. So let's say we want to get rid of this particular background here, and we want the part color to be shown here. So what we can do is we can use the selective color mask option. Just click on this pick color button, and you can go back to your decal preview, not on the graphics area, but on the decal preview. You can choose any particular color, and SolidWorks will get rid of this color. You can see that in the preview itself it's updated, in the model also it's updated. So basically here, if you go, you have selected a one particular color, which is white. Basically SolidWorks is getting rid of that color. Let's do the same with red and see how it looks. It's not looking so good because you are missing some lines here. We'll get rid of this. This is looking okay for now. So what we can do is we select OK. We need to have this view decals turned on to look at the decal that you have added. So this is the decal that we have added, and let's go back and see how it's going to look in the assembly level. Let's have a preview. It's looking really good. or maybe if you want to remove that mask and retain the white color, that is also fine. We can do it, because at times it will leave some white um, images around it, white color around it. So let's get rid of that selective mask. I don't want that. I just want you to understand that there is option. So let's edit the decal. At any point you can do all these changes. I'll get rid of that white color and say OK. Further, I'll show you one more option. If you have an alpha, if you have an image mask file like this image, you can just drag and drop it. Let me rotate it so that there you go. And if you'll go back to the image tab, you can see that this is an image mask file. So it's already masked and it's ready to go. So you can click OK. But if you don't want that no mask, you can also use that option. Or if you want to use selective color mask and get rid of the color here, you can do that as well. So these are different ways of doing it. I don't actually want this. I just wanted to show you the other two options we have. Or you can use alpha channel image if you have one. So let's go back to the assembly window. So when we are talking about the workflows, there are different ways to go about it. Right now I have a preview window, which is basically a small window inside SolidWorks. This is best suited when you have a dual monitor. You can just drag this onto the second monitor, and you can keep working on your SolidWorks, keep on adding appearances, and see on the other monitor how it reflects. The second way to go about this is we have an integrated preview. What integrated preview accomplishes is it renders the complete graphics area of SolidWorks. This is best suited for people who have a single monitor and who want to always have a preview of what they're doing. I don't usually use this because even a small rotate or zoom will again start the rendering. So it's a time-consuming process, as you understand, and you don't want this to affect your speed of work. So instead, single monitor users can do something like a split window. What you can do is you can split your windows into a 4 or 2 views, whatever you want, and then have the integrated preview. What this does is it only gives you a preview in one of the 4 split windows, and the other 3 will be remaining as is. So you can keep on working on SolidWorks on one of these windows and look at the changes on the other window. So let's go back to the single window mode. Okay, I think we're almost done with the decals. So let's go with the next part. Let's add a couple of cameras and see how it works. For now, I don't want this tab or task pane, so I'll get rid of it. So on the display manager, you have 3 tabs. The first one is appearances. The second one is decals. So if you go to decals, you can see all the decals that exist in this assembly, and you can edit them or remove them from right here. Or you can go to the third tab, which is scenes, lights, and cameras. We'll talk about scenes and lights in a minute, but for now, let's understand how cameras work. Cameras are extensively used, especially when it comes to walkthroughs. But I highly recommend using cameras for rendering also, so that you can have a select view. At people who don't use cameras may at the max use a perspective view to get a realistic view of their models. But other than that, you won't be able to do much unless you're using cameras. So what I'll do is I'll add a couple of cameras here and see how it goes. So you can right click on this option, camera, and you can add cameras. So what this does is it immediately splits your window into 2, as I mentioned in the PowerPoint. The first half will reflect the camera position and what the camera is looking at, etc., etc. The second half is actually your 3D model as seen from the camera lens. So you can basically call this a camera output, and you can rotate using either of these windows for positioning purposes. This is just to place the camera. Once we place the camera, the option will be locked. So let's see how it goes. What we can do is we can target a particular section of your 3D model. It can be a point, it can be a face, or it can be anything, any geometric entity. So in this case, what we'll do is we'll select this particular point. You can see the point selected here. Yeah, let's keep this. And you can see the depth of view and other. You can zoom in, zoom out, or you can position the camera by using the thumb wheel here. You can rotate the camera, or you can fix it, or you can position by selection. You have a lot of options here. So what we'll do is we'll see how we can get a very good view of our model here. So as I said, you can either play around with the left window or the right window. Usually the right window is very easy. So let's say if you want to have it in this particular fashion. Okay, this is good enough for me. So this is how your camera will be placed. And as I said, you have a lot of options here. You have a particular type of lens to be used. If you want to use 35mm lens, or if you want 24mm, 85, 135. Let's go back a little so that we see the reflections and the shadows. This is fair enough. And we have one more advanced option wherein you can actually play around with the depth of field. This is really interesting when it comes to when you want to have a particular focus on a particular section of your model and then get rid of the others. So what you can do is let's say we are focusing on this particular area of the car. So you can see that on the right we have everything in focus. Let's say we reduce this field of focus by a big amount, and we'll start the preview window. I have some questions, but I'll get to the questions in just as soon as we finish the content here. You can see the integrated preview on the right. What I'm trying to do is I'm trying to show you how we can focus on particular section of the model and adjust the field, depth of focus from there. It's taking quite a bit of time, so let me change it to 1 and see how it works. Let's just accept this for now so that the preview will be faster. So I have an integrated preview now. And by the way, just to emphasize on the need of a good graphics card, you need to have a professional graphics card, maybe NVIDIA Quadro series. I have a 1 GB graphic card, and still you can see how how resource hungry this particular process is. I think the focus is pretty much on all the areas here, so which I don't want. Anyway, and I'll show you some images where we, by changing around the field of focus and the depth of field, you can exactly, focus on particular point. Here I have the point here, so I think that's what causing. No, not this point. Let's go to camera 1, and in this camera 1, if we turn on the depth of field, sorry, and we have, let's say, integrated preview. Here currently our depth of field is 3 mm, and you can see that all the areas of the rendered image are pretty much in focus. Let's say okay and see how it works. This is going to take 10-15 seconds to render, but I just want you to understand that by having the proper depth of field, you can have all the components of your design in focus. Or let's say you want to have some of the components in the background which are to be blurred out. What we can do is we can quickly edit this particular camera and change the depth of field. Basically, let me put it at 1. It's trying to render it, but after rendering it, you'll notice that the back components after the seat and maybe a part of the seat also will be blurred out, because the point we have selected is near the steering. Yeah, even though it's trying to render it, you can now see that whatever the portion of the car it's trying to render, it is out of focus, and the focus is on the red part, the red Lego piece here, and the seat and etc. are all blurred out. So this is really nice, like when you're working with heavy machinery and if you want to only focus on particular part of your machinery and you want the not so important detail to be blurred out, you can use this. Yeah, you can see that all these components are out of focus. It's still trying to finish the render process, and you can see that this particular Lego piece and the tire, the front tire here, are very much in focus, whereas this particular tire is out of focus. So you get the picture. You can play around with a lot of settings here. I think we're running out of time, so let's wrap up with the cameras. Let me see if I have anything else to show on cameras. I think yeah, we covered a good deal. You can add as many cameras as you want, and then you can lock the camera from here. Like I have 2 particular cameras here, the one which we've created and the couple of ones which I already had. So, but you won't be able to rotate anything here or zoom because the camera is locked. If you want to go back to your CAD, just go back to your isometric or trimetric views. So now let's go to scenes. So as I said, every scene, any component that you start making in SolidWorks, it can be from a template or all from a scratch. It will have a basic scene. So in this case, we'll go and see where the scenes are located. So on the right task pane, we have 3 different scenes: basic, studio, and presentation. So let's see how these work. If you want to add a particular scene, like let's say I want to have soft spotlight, double click the scene and the scene will be added. As I said, every scene will have some lights added, 1 ambient light and 3 directional lights bundled with it. So here in the scene spotlight, you can rotate around and you can see that what they mean by a spotlight. Basically, it's a box in which your model is placed, and you have a light source on the top, and you can place your model on at any given angle that you like, and then you can start rendering it. Again, you have options of a lot of options like controlling the shadows. I told you how we can edit this. So I'll edit the scene, and you have here something called as floor reflections and floor shadows. Let's select floor reflections as well as floor shadows, and here we have something called as the floor offset. So to match or to align your reflection and the shadow with the car tires, you can play around with this, but it's very difficult when it comes to curved surfaces like tires, etc., because they expect them to be tangent with each other. But still, you can adjust them so that it looks realistic enough. Earlier, there was a huge gap, so now we have corrected it. Or one more thing that you can do is you can use a solid color instead of having 3 or 4 different colors with a soft light. You can have a single color as such, or you can have let's say something like a gradient, wherein you'll be having 2 colors. One is black, one is the top color is gray. So this again gives you a fantastic gradient effect. Or you can choose something like an image. Let's go and first log this up in my camera view, and let me edit the scene. I want to use an image. So if you have an image, something like a background image, you can just bring it into SolidWorks. Something like this. I have a background, it's a 2D image, and again you have control of floor shadows here, and if you want you can have floor reflections as well, and then you can start rendering it. Since a big part of it is a 2D image, it will only render the particular relevant 3D part, and this will be relatively quick, and I'll show you a sample output that we got out of it. So you have a lot of different scenes. You have presentation scenes like a 3D environment of courtyard or factory background or office space, or you have studio scenes where you have different types of lighting effects, and you have some basic scenes like 3-point beige and 3-point blue, which are basically default scenes which are used with your templates. So this is how it's going to be your integrated preview, and at this point you can start rendering it. But let me do it separately. I'll show you something called as options, PhotoView 360 options. So this is where you set all the all your requirements, like the image size. So you can specify a custom image size, or you can choose from one of the standard presets. You can choose the format in which you want your output to be, JPEG or any other format, BMP file, etc., etc. And then you have 2 settings here: preview render quality and final render quality. So usually what this means is this directly translates into the rendering processing times. So all the integrated preview or the preview window rendering, basically you can have it at good or better depending on how you want it to be, but never have it at best and maximum, because it will be a huge time consuming process. But for final render, always go for best, and if you want the maximum, you can go for the maximum quality. I have a table on my PowerPoint which basically talks about the differences between good, better, best, and maximum render qualities. Basically the number of reflections, number of refractions, and the number of illumination rays. So basically everything has to do with the quality here. So the better quality you want, and the higher time it's going to take. So you can have caustic options, which is a little bit advanced for this webinar, so let me skip it for now. And yeah, basically let's choose best for the final render. We have all the options set, and now we can click on final render. What this does is it opens up the rendering window. This is not a preview, this is a final rendering window. So it will open up a preview first, and then it will start rendering. So you can look at the status here that it's going through so many iterations and so many passes. we have selected I think best quality, so it's gonna take a couple of minutes. So again, in this particular image, we have used a camera to set our model in a particular angle, and we have placed a 2D image, and we have used decals. We have used some scene settings, like we have floor offsets and floor reflections coming in from the scene. We have some basic default lighting coming from the scene, like in the form of ambient light and directional lights. Unfortunately, we couldn't get to see a lot of lighting options today. Maybe on the next topic, next time when we do a webinar, it will be on the advanced options of PhotoView 360. So that time we'll take in-depth look of at all the lighting options in SolidWorks, as well as we'll do some animation, rendered animations, because most of the time when I see someone doing an animation in SolidWorks, it will be just basic CAD animation, but you can do a rendered animation in SolidWorks, and we'll see how we do it in the next webinar. So it's on the fourth step, 4 out of 10. So let me start taking questions. I have a bunch of questions already. I have a question. If you can see the same pictures on this print, basically if you are saving this in high quality image, yes, you can print it out in the exact same fashion. So what you see is basically what you get. You can definitely see the logo on prints. As I said, again, what you see is what you get. I have a question about SolidWorks decals in Pack and Go. Unfortunately, I don't think this is a possibility. Maybe you have to add the decal again in your image library. But let me check. I'm not too positive on this, but let me check and get back to you on this. I have one more question regarding how to mask a decal on a curved surface. Yeah, it's basically the same exact process that we followed. The surface has nothing to do with it. It's all about the selection color mask that you pick on the left on the property manager. See, I have a question about the size of the rendered image. Will it be low? It again, it's completely dependent on you. Currently I'm printing out a huge file, 3000 by 2000 in size. So it's a high quality image that I'm taking it out. But if you want, actually, I mean, this is something close to 6 megapixels. If you want it to be low, you can definitely control that. I have questions about scenes. How do you make your own scenes? What I would do is I would start off by using one of the existing scenes, editing them to such an extent that they will suit my requirements. Again, you can make your own scenes. I have one more question on the logo picture on the SolidWorks prints. Yes, you can definitely see them. As I said, this is just an image. Now, there is no SolidWorks involved. There is no anything CAD involved here. It's just a plain image file. It can be a JPEG file, or it can be any other format. We actually get to save this after the rendering is done. So yeah, you can basically see the logo picture. Okay, it's taking too much time. I think I went a little bit overboard with my size and quality requirements here. Anyway, it's going on. That's a good thing. Yeah, I think this rendering is going on. I have another question regarding more texture materials in library. You can definitely add your own material. You can edit the current material thing. You have places where you can go and download them also. I have a question about how 3D VR Composer and PhotoView 360 are linked. Actually, out of the top of my head, I can say that they are not linked at all. This is a default rendering engine for SolidWorks design engineers, and 3D VR is a more specialist application. I will definitely share this complete PowerPoint. I have a request to share the link for downloading. I'll definitely share the links with you. Okay, I think we are out of time. It's 12:01. So thanks everyone for joining us. Let me put up my contact details so that if you have any questions, please drop me an email at pradeep@beacon-india.com. And again, thanks, a shout out to Mr. Rob Rodriguez, Access CAD LLC USA. The complete data set and the presentation flow was his. He did this at SolidWorks World 2012. So I just wanted to thank him. Let's wait up for this rendering to be done. I have some sample outputs. Let me just go through the output here. So this is how it's going to look after you render it. I actually digged it out yesterday. You can see the shadows and the reflections are accurate. Basically, all of them due to the settings. Okay, thanks everyone. Thanks for joining the webinar. We appreciate your time. If you have any questions, please drop me an email at the email ID shown.